Here's the problem statement. It says find all functions f from positive integers to positive integers such that m squared plus fn divides, this is the division symbol, m times fm plus n. What we do with Olympiad problems involving functions is that we usually plug in some special numbers to the function and try to get special values, and we will do nothing else in this question. First, before starting, we need to know two facts. One of them is a and b are positive integers. Then, if a divides b, we know that a is smaller than or equal to b. The other fact that we will use is that if a divides b and b divides c, we know that a also divides c. Now let's insert m equals fn and see what we will get. Since fn is gonna be a positive integer and m is also a positive integer, we can do this replacement without any errors. So let's do it. Fn squared plus fn divides fn times fyfn plus n. So as you see here, fn divides this left hand side, so it should also divide the right hand side. But we also know that fn divides here fn times fyfn, thus it should also divide n. So we get fn divides n, which means fn is smaller than or equal to n. Now let's get this and hold it somewhere. Now let's insert m equals n. What we'll get is n squared plus fn divides n times fn plus n. So from the fact 1, this shows that n squared plus fn is smaller than or equal to n times fn plus n. Now let's rearrange this inequality, sending this n to left hand side and this fn to right hand side. We get n squared minus n is smaller than or equal to n times fn minus fn. Now the left hand side can be taken into parentheses of n minus 1, which is n times n minus 1. And the right hand side is in fn parentheses, again n minus 1. From here, let's assume that n is not equal to 1 and divide by n minus 1. We will look for n equals 1 later on. Now this shows n is smaller than or equal to fn. But we also had this other inequality here, which showed fn is smaller than n. Now we get n is smaller than fn. What this means is that fn equals n, which this is the only function that holds. Now for the case n equals 1 we kept. Remember that we didn't divide with n minus 1 in the first inequality, thus we can still use this fact to work with n equals 1. This shows f1 is smaller than or equal to 1. But this function is defined from positive integers to positive integers. Thus, any number smaller than or equal to 1 and still a positive integer is just 1. Thus, f1 equals 1, which holds with the statement that fn equals n. So the answer is that the only function that holds this system of division is fn equals n.